So this is National 4, National 5 Chemistry. We are looking at Unit 2, Nature's Chemistry, and we're still looking at hydrocarbons, but this time we're looking at a second homologous series, and we're going to be looking at what we call alkenes. So our learning intentions are to be able to name and draw the structures for compounds known as alkenes, and to be able to give the general formula for the alkenes. Now, the alkenes, they are a homologous series of hydrocarbons, and their names end in ene, so that is ene. Remember that the previous homologous series were alkanes, where they ended in ane. This one ends in ene. And what makes an alkene different from an alkane is that alkenes contain a carbon-to-carbon double bond. So at some point in an alkene, you will see two bonds between the same two carbon atoms. Now, keeping this in mind that we need a double bond between two carbon atoms, what do you think the first member of the alkenes will be? And using the prefixes that you learned last time, what do you think its name might be? Well, the first one is actually ethene. Because you need a double bond between two carbon atoms to form an alkene, there's no such thing as methane, because there's only one carbon atom and it's incapable of forming a carbon-to-carbon double bond. The first alkene is ethene, and it has the molecular formula C2H4, and it's got a structural formula of carbon, carbon, two bonds between them, and then we fill in the rest of the hydrogen atoms. So two hydrogens on the first carbon, two hydrogens on the second carbon. So if the first one is called ethane, what do you think the names of the next two alkenes would be? Well, firstly we have ethane, then we have propane, butane, pentane, hexane, and we would have heptane and octane as well. The molecular formula: C2H4, C3H6, C4H8, C5H10, and C6H12. And what you notice is that each one of these molecules just contains one carbon-to-carbon double bond, and the rest of it looks just like an alkane. And we also have heptane and octane. Now remember, the first one had a formula C2H4, the next one C3H6, and the third one C4H8. What do you think the general formula for alkenes might be? Well, for alkenes, the general formula is CnH2n. So a bit easier to remember than for alkanes, because whatever the number of carbon atoms there is, the number of hydrogen atoms is just going to be double that. Now, some of the uses of alkenes. Well, alkenes can be used as fuels. They can also be used as solvents, so to help us solve things. And alkenes can be used to make plastics, and alkenes can also be used to make vinegar. Now, one term that you will hear a few times in Unit 2 is the term functional group. And a functional group is a group of atoms bonded in a particular way that are responsible for the characteristic reactions of a particular compound. So it is a set of atoms bonded in a particular way that makes that group of chemicals react in a similar way. And the functional group for alkenes is the carbon-to-carbon double bond. That's what makes alkenes different from other homologous series. Now, when it comes to naming alkenes, the system is very similar to naming alkenes, except the functional group must be included as part of the longest chain, and you need to show a number that indicates the position of the carbon-carbon double bond. So, firstly, we're going to look at the easier example of straight chain alkenes. And the first thing you need to do is decide how many carbons are in the chain. And you number them, starting with the functional group on the lowest number of carbon atoms. So if you see the double bond is on one end of the chain, you start at that end. You decide which carbon atom number the functional group is on. Remember, the functional group is going to be on two, well, it's going to be between two carbon atoms. Use the number that's the lowest of those two. And then you set up the name. So the number of carbon atoms tells you the prefix. So that's your eth, prop, etc. Then you put a dash, and then you put a number that tells you what is the lowest number that the functional group is on. Then you put another dash, and you give the final name ending in ene. So for example, here, we have got 4 carbons. So 4 carbon chain, that means it's going to be bute. The functional group, in this case, it actually doesn't matter which end of the compound we start on. The functional group is always on carbon number 2 for the lowest number. And that makes the name bute for 4 carbons, then a dash, then 2 to tell us that the functional group, the double bond, is on carbon number 2, and then another dash, and we finish with ene to let us know that it is an alkene. With this one, well, we've got 3 carbon atoms, 1, 2, and 3. Now remember, we want the double bond to be on the lowest carbon possible, so we start counting from the right-hand side this time. The double bond is on carbon number 1. So this is going to be prop 1 ene. But this one could be shortened to propane, because actually, if the double bond was on the other side, if it was between carbons 3 and 2, what we would do is we would actually just start counting the other way, and it would still be prop 1 ene. So here we've got 4 examples. I suggest that you pause the video to give yourself practice at naming these. So if you do that now, and hopefully you've unpaused the video having had a go at these different compounds. Well, the first one is prop 1 ene, or propane. It's absolutely fine for that one. And the one at the top right hand side, well, the longest carbon chain is 5, so it's going to be pent, and the lowest number carbon that the functional group is on is 2, so that is pent 2 ene. The next one is bute 2 ene, and the final one is ethene. Now we can also, just like with alkanes, get branched alkenes. In this case, you start by looking for the longest carbon chain that contains the double bond functional group, and make sure that you number the carbons so that the functional group is on the lowest carbon possible. You then look to see if there are any branches, and if there are branches, which carbon atom these branches are on. Now, importantly at this stage, whatever side of the molecule you used to give the functional group its number, you have to keep using that same numbering system to find which number carbon the branch is on. Okay? Then once you've worked out what number carbon the branch is on, you need to look at how many carbon atoms are in the branch, and then you put it together. So you're looking for the carbon number the branch is on, then how many branches there are, then how many carbons are in the branch, and then finally how many carbons are in the longest chain, including the functional group. So this is an example. That is 3-methyl-but-1-ene. So if we start the longest chain containing the functional group is that starting on the carbon on the left-hand side and counting across 1, 2, 3, 4. That tells us there's 4 carbons in the longest chain, so it's going to be based on but. The functional group is on carbon number 1, so it's going to be but-1-ene. Now we go looking for the branch. Well, the branch is on carbon number 1, 2, 3, and the branch contains 1 carbon. So it is 3-methyl-but-1-ene. 4 carbons in the functional chain, 1 branch with 1 carbon in it, carbon to carbon bond on number 1. Here we've got another example. So this one, we've got to make sure, remember that we want the branch and the functional group to be on the lowest carbon possible. So the longest chain contains 4 carbons. There is 1 branch, and that contains 1 carbon atom, and the carbon to carbon double bond is on carbon number 2, and the branch is also on carbon number 2. So it is 2-methyl-but-2-ene. Now, if you looked at the molecule the other way round, so rather than looking at it from the left-hand side, if you looked at it from the right-hand side, you might think that it's 3-methyl-but-2-ene, but we need to have the numbers as low as possible. So if the branch is on one of the carbons that has the double bond, we want to use the lowest possible number for that carbon. So it's 2-methyl-but-2-ene. So that has been us going over alkanes. We learnt that alkanes end in ene. They have a functional group which is a carbon to carbon double bond. We learnt that the general chemical formula for alkanes was CnH2n. And we learnt that some of the uses of alkanes were as fuels and for making plastics and vinegar. And we learnt how to name straight chain alkanes and also branched alkanes. So that has been our second lesson for Unit 2. I will catch you next time.